our lesson is going to be on cube roots today, and so there is a different rule for perfect cubes when you're talking about exponents. So just like when we did exponents with just a square root, we said it had to be a multiple of 2. So cube root would have to be a multiple of 3. Okay, so a multiple of 3 would be 3, 6, 9, and so on. So if I ask you what is the cube root of a to the 6th power and b to the 8th power, you would have to break these exponents down into perfect cubes. So remember when we broke down for perfect squares, it had to be an even number. For perfect cubes, you want it to be a multiple of 3. Now, obviously, 6 is a multiple of 3 already. So when you take it out of the cube root, you divide it by the index. The index here is what? 3. So what is 6 divided by 3? 2. So that goes on the outside. Okay. Now, you still can simplify this b to the 8th, because just like we would break down those exponents to even and an odd number, you can break down the cube roots to a multiple of 3. So I'm going to break down this cube root to a 6 and a 2, because it has to be a multiple of 3. So the largest multiple of 3 in the number 8 is 6. 3, 6, 9. You can't go to 9. That's too far. So 6. So now I'm ready to take out b to the 6. So I'm going to do what? Divide it by the indexed. So the index is 3. So what is 6 divided by 3 again? 2. So I'm taking this out. And then I'm left with b squared underneath. So that stays there because it is not a perfect cube. Okay. So let's try another example. And I'm just working with variables because the numerical part we're going to get from the calculator in a minute. So just want to make sure you understand how to do the variables. So let's say we had y to the 5th, z to the 7th. Okay. So is there a multiple of 3 and 5? Yes. What's the highest multiple of 3? 3. So I'm going to do y to the 3rd times y to the 2nd. Okay. Is there a multiple of 3 to 7? What's the largest multiple of 3? 6. So I'm going to do z to the 6th times z. So now I'm ready to take out the perfect cubes. So that means I'm going to divide all of those perfect cubes by 3. Well, 3 divided by 3 is 1. That goes on the outside, y to the 1st power. Z to the 6th divided by 3, I get 2. And then I simply write what's left will be the y squared and the z. All right, so now we're back on page 13. So this is where we're going to now use the graphing calculator to help us simplify these cube roots. So we're going to go to the calculator. We're going to put in 64. So hit your, let me just clear this out. All right, so hit your y equals key, clear whatever's there, put in 64, divided by x to the 3rd power. Okay. And then go to the table, so second graph, and look in the y1 column where, you get the last whole number and everything after that will repeat decimals. So it looks like it's 4 and 1. So whenever 1 is in the y1 column, that means it's a perfect cube. So you simply write 4. Do not write 4 rad 1. Okay, because when a 1 is there, that means it's perfect. All right, let's go ahead and now do 40 divided by, hit your y equals key, clear that out. Okay, so 40 divided by x to the 3rd Oh, sorry. All right, go to the table, second graph. All right, so did everybody get 2 and 5? All right, so we're going to say 2 and then the cube root of 5. Okay, so make sure you're not doing just square roots. These are cube roots. All right, I want to do number 3 because it has a negative in it. So we're going to go to our calculators and put in negative 48. All right, so negative p is by enter, 48, divided by x to the third. Okay, second graph. And where is the last integer, I would say? Is it 2 and negative 6? All right, so now, because the negative 6 is in the y column, we don't put this negative under the radical. It'll actually go with the 2. Okay, so when we write it, we're going to write it as negative 2 and then the cube root of 6. Okay, so negative 2 and then the cube root of 6. All right, let's do number 5, because what happens if there's a number already there? We already know with square roots you multiply it. You do the same thing for cube roots. Okay, so we're going to put in negative 135 this time. Okay. So I'm going to hit my y equals. Okay, negative 135. Okay, divided by x to the third power. Okay, we're going to go to the table, second graph. All right, what did you guys find for this one? 3 and negative 5. All right, so we're going to go back to our worksheet. All right, so basically it's going to be negative 5 and 3. Or what was it like that? How was it on the?
Negative 5 and 3.
It was 3, negative 5. Okay, let me change that. So this is 3, 5. All right, now notice there's a 2 outside of here. So what do you think I'm going to do with that negative 3 and that 2? We're going to multiply. So that's going to give us what? Negative 6 times the cube root of 5. Okay. So don't keep the negatives under the radical. They go outside of the radical. Okay, just make sure you know that. All right, now let's take a look at some ones that have variables in it. So like number 13. Okay, we did 135 already. Did we do 135? We just did it. 6 and 5. So 13 just has a positive 135. So we already know this is going to be 6 and 5. Did we multiply it? Yes, you're right. 3 and 5. Thank you. So we're going to put 3 and 5 there. And then we're going to break down these exponents, because this is an 8. So what is the largest multiple of 3 that's an 8? 6. So we're going to say x to the 6 times x squared. And then how about for 5? 3 and 2. All right, so you just want to make sure you break those down to multiples of 3. So we can now take out the 6, and we divide it by the index. So what's 6 divided by 3? 2, so that's going to be x squared. Take out the y to the third. What's 3 divided by 3? So y to the first. And then what's left? You're going to say the cube root of 5x squared y squared. All right, so let's look at 18. Okay, now I go ahead and find out what the cube root of 16 will be on your calculator. I'll wait for an answer. All right, 2, 2. So I'm just going to put that up here. And then I see there's a -4 on the outside. So now that's going to become what? -8. Very good. So I'm going to now break this 8 down to 6 and 2. And I don't need to break down the 6. It's already a multiple of 3. All right? So now I'm ready to take out any multiples of 6. So I'm going to leave the -8. I'm going to take out x to the 6 divided by 3. That's going to give me 2. And then take out that again, the y to the 6. That's going to give me 2. And then I'll have the cube root of 2x squared. Is that correct? Okay. Came in